Let us now discuss the background of the plastics and resins under the petrochemical industry. So in today's world, we are surrounded by plastics, also known as plastic resins. Their popularity and overwhelming use are attributed to the fact that their properties and design technologies are beyond any other material. Plastic resins are not any one material, but instead a family of related materials with various properties that can be formed to meet the requirements for the bottles, containers, closures, and caps used for your drugs, vitamins, and other pharmaceutical and medical products, as well as container products. Plastic resins are created by heating hydrocarbons in a process known as the cracking process. The goal is to break down the larger molecules into ethylene or propylene, which comes from crude oil refining process. Let us now discuss the history of the industry. In 1862, the first man-made plastic was created by Alexander Parks. The material, also called Parksine, was an organic material derived from cellulose that once heated could be molded and retained its shape when cooled. In 1907, the birth of the modern plastics era came with the invention of Bakelite by Leo Baekeland. It was the first synthetic plastics which was derived from fossil fuels. Baekeland used phenol, an acid derived from coal tar. In 1929, Edward Simon isolated a substance from natural resin. However, he is unsure of the discovery until later when Hermann Staudinger discovered that it was comprised of long chains of styrene molecules, which was a plastic polymer later dubbed as polystyrene. In the year 1930, American scientist Wallace Carothers first discovered that alcohols and carboxyl acids could be mixed to create polyester. In 1933, polyvinylidene chloride, or saran, also called PVDC, accidentally discovered by Ralph Wiley, a Dow Chemical Lab worker. In 1937, polyurethanes was discovered by Otto Bayer and co-workers, which was later published and patented the chemistry of polyurethanes. In the year 1938, polytetrafluoroethylene or PTFE, also known as Teflon, was invented by Roy Plunkett. In 1939, nylon and neoprene, considered a replacement for silk and a synthetic rubber respectively, was invented by Wallace Hume Carothers. In 1941, unsaturated polyester, also called PET, was patented by John Rex Winfield and James Tennant Dixon. In the year 1938, polytetrafluoroethylene or PTFE. Okay. So in the year 1938, polytetrafluoroethylene So in the year 1954, styrofoam, a type of foam, polystyrene, was invented by Ray McIntyre for Dow Chemicals. In the year 1970, thermoplastic polyester, which includes the trademark Dacron, Millar, Melinex, Teijin, and Tetero, was invented. In the year 1978, the invention of the linear low-density polyethylene was first done.
As mentioned before, the sector's relationship of the industry to each other has close connection that it basically provides the support and raw materials needed for other types of businesses. Next, the leading companies in the petrochemical industry, particularly in the plastic and resin materials, are Dow Chemical, ExxonMobil Chemical, Formosa Plastics Corporation, and Sumitomo Chemical. The Dow Chemical Company, located in the United States, was founded in 1897 by Canadian chemist Herbert Henry Dow and is the world's largest supplier of plastics, including polystyrene, polyurethane, polyethylene, and polypropylene. The firm operates in 175 countries and employs 46,000 individuals throughout the world. though has a significant presence in the Middle East with a group of elite joint ventures with some of the region's biggest names. On the other hand, in the local market, JG Summit Petrochemical Corporation or JGSPC is the Philippines' largest polyolefins manufacturer, and its Evelyn brand PE and PP resins are of the highest quality available anywhere. Polyolefins are thermoplastics made up of polyethylene and polypropylene. They are mostly made from oil and natural gas using ethylene and propylene polymerization process. That's all for the major companies involved in the petrochemicals industry.
The petrochemical industry plays a significant role in the chemical industry since there is an increase in demand for synthetic materials in today's manufacturing sector and economy. Here are some of the important common products associated with the industry. First off is the ethylene. Ethylene is a colorless and flammable gas that is often referred to as the king of petrochemicals. It got its title due to the number of in-demand commercial products that could be produced from its derivations. It is mainly used in the manufacturing of wire coating, medical devices, and packaging films after undergoing polymerization and producing polyethylene. Next is the propylene. Propylene is another colorless and flammable gas that is considered as one of the important chemicals in the petrochemical industry, following closely to ethylene. Propylene is mostly used as a feedstock in manufacturing resin and elastomer after undergoing polymerization to produce polypropylene plastic. The produced polypropylene plastic is then used in manufacturing films, synthetic fibers, and plastic bottle caps. Lastly is the butadiene, which is a colorless and non-corrosive gas that is commonly produced through a high temperature cracking of petroleum distillates. It is a versatile raw material that is considered as a major component when it comes to manufacturing synthetic rubbers, polymer resins, and a few chemical intermediates used in the production of nylon fibers and polymers such as chloroprene and adiponitrile.
For the process of making natural rubber, we begin with harvesting latex from rubber trees through scoring or cutting, which is the process of making a single cut into a bark of the tree. Next is coagulation. It is the process that curdles or thickens the polyisoprene into a mass. This process is accomplished by adding an acid such as formic acid to the latex. Water is squeezed out of the coagulum of rubber using a series of rollers. The resulting thin sheets, about 1/8 inch thick, are dried over wooden racks in smoke houses. Compounding adds chemicals and other additives to customize the rubber for the intended use. The additives must be thoroughly mixed into the rubber. Shaping rubber products occurs using four general techniques, which are extrusion, coating or molding, and casting. Vulcanization completes the rubber production process. It is by adding sulfur to rubber and heating the mixture to 280 degrees Fahrenheit for about 5 hours. The inputs are rubber tree, chemicals, and additives, and for the byproduct or emissions, we have carbon monoxide. For making synthetic fibers, we begin with monomers undergoing polymerization. It is the reacting of small molecules together in a chemical reaction to form polymer chains. Polymerization processes are performed in the presence of catalysts. Next is pumping. Molten polymer is pumped through a filter bed and then through small deep holes. Both units will lead to high pressure drops along the flow direction of viscous liquids. Then filtration. It is used to clean the spinneret plate. Then spinning. The fibers are formed by extruding molten polymer through small holes in the spinneret plate. There are three methods of spinning, which are melt spinning, dry spinning, and wet spinning. Stretching or drawing the filament is the process of pulling the long polymer chains to align along the longitudinal axis of fibers, grouping together and developing cohesion. During the drawing process, the polymer chains slide over each other as they are pulled to align along the longitudinal axis of the fibers. Lastly, finishing and dyeing. During the final process, synthetic fibers are processed with many chemicals to develop and improve their appearance. The dyes can be added to the molten solution before spinning the fibers. Fiber is usually dyed after spinning by pigments dissolved in boiling water baths. The inputs are monomers and catalysts, and the byproduct or emission is carbon monoxide.
Now let's talk about the production of the key products or major products of the petrochemical industry. Remember that these were produced from the basic chemicals which is discussed from the previous video. Let us start with plastics. The first process is called polymerization, in which olefins like ethylene and propylene, or monomers in short, are combined together to form a higher molecular weight hydrocarbons called polymers. There are two different mechanisms, namely addition polymerization and condensation polymerization. Examples of addition polymerization include polyethylene and polystyrene, while polyester and nylon are products of condensation polymerization. Next is compounding, where various materials were melted and blended together with the polymer in order to produce different formulations of the plastics. Then it undergo pelletizing, where the materials were processed to form into pellets. These pellets are then shipped into different factories to be molded into different materials such as plastic bottles, food packagings, and many more. Our inputs include monomers, as mentioned, such as ethylene and propylene, our catalyst, which is used in the polymerization process. The byproduct or emissions from the plastic production includes chemicals such as trichloroethane, acetone, and many more.
The chart shows the increase of global plastic production measured in tons per year from 1950 through 2015. In 1950, the world produced only 2 million tons per year. Since then, the annual production has increased nearly 200-fold, reaching 31 million tons in 2015. For context, this is roughly equivalent to the mass of two-thirds of the world population. The short downturn in annual production in 2009 and in 2010 was predominantly the result of the 2008 global financial crisis. A similar dent is seen across several metrics of resource production and consumption, including energy. In addition, the figure shows the plastic production allocation by sector for 2015. Packaging was the dominant use of primary plastics, with 42% of plastics entering the use phase. Building and construction was the second sector, utilizing 19% of the total. Primary plastic production does not directly reflect plastic waste generation, since this is also influenced by the polymer type and the lifetime of the end product. For the rubber, the production of synthetic rubber has considerably increased in this century. In the year 2000, around 10.9 million metric tons of synthetic rubber was produced, and this amounted to reach over 14.4 millions of metric tons in 2020.